Alright, in a previous video, we talked about the circumference and area of a circle. So if you haven't watched that yet, or you forgot what those were, please go back and check that video. In this lesson, we're going to actually use those ideas and further them to talk about the arc length and sector of a circle. So you're going to see very similar formulas being used as circumference and area, but it's a modification of them. An arc length is a proportion of the circumference. Is a portion, a portion, yeah. It's a portion of a circumference. All right. So arc length is different than arc measure. So we've talked about arc measure before being a degree, but an arc length will be a distance. It's going to be a length. So just like in we talked about the angle, central angle being equal to the arc measure. Right now we're talking about arc length, so we're talking about how long the length the arc is. Okay, so let's say I have this arc here. Okay. I can find the measure of it, which would be a degree, but more specifically, right now we're talking about an arc length. So we're looking for how long this is in terms of like centimeters or inches, or feet or yards. Okay. Now the formula for arc length looks very similar, and we're going to use the variable s. Now I'm not really sure why we use s. I know it's confusing, but we're going to use s for arc length. Okay. We're going to take x degrees over 360 times 2 pi r. Okay, and that's how we're going to do it. So a couple of variables we're using. We're using x and we're using r. R you've seen before as the radius, and x is going to be the central angle. So just like the arcs we've talked about before, arcs can be split up by a angle that's coming from the center, or we call that the central angle. And I'm going to label that as x degrees. Okay. All right. So as you can see in the formula, you actually have the circumference formula that we talked about in a previous video. All we added to it was a fraction in the middle, in the front of it, and that's what makes it a portion of a circumference. If you actually took this fraction, right, think of it as a percentage of the whole circumference. 360 is your total, and we only want the chunk that we're looking for, which is going to be located or identified by x degrees. So we'll see how that looks like in our example problems. Okay. So the two things we really need are radius and the central angle if we can find it. Okay. So example number 1, EB is 15 centimeters. So I'm going to label that EB is 15 centimeters, and I can see EB is my radius. We want to find the length of CD. So we want to find this here, CD. Let's actually change this to make it a little easier since this is our first problem. Let's change it to CB. So instead of CD, let's do CB. And I want to find this arc, CB. Okay. So we want to find the length, not the arc measure, but the arc length. So with that, I'm going to write down all the information I have. I know that we just said that the radius is 15 centimeters. And the central angle that goes with that arc length is 68 degrees. So my x value is 68 degrees. and we're going to plug it in to find the length of CB. So S equals, the formula is, S equals x over 360 times 2 pi r. And let's plug in x, the degrees, and 15, the radius. I get 68 degrees over 360 degrees times 2 pi times 15. Couple things going on here, so a calculator would be nice, but I'm going to simplify everything first before I do the calculator. Okay, so I'm going to take the 2 and the 15 and multiply it together to get 68 over 360 times 30 pi. Simplify a little more using the calculator, or you can go all the way if you want, but I'm going to do 68 times 30 to get 2040 pi divided by 360. Okay, the 30 multiplies with the 68 and the pi goes with it. So you can actually leave the pi on the side if you want. Now to get a final answer, I'm going to put all this in the calculator. So I'm going to do 2040 divided by 360. Get my answer there. And I'm going to multiply by pi. Final answer, the arc length is 17.80 centimeters. Okay, so make sure you know how to plug into the calculator to get 17.80. If you didn't get that with the calculator, I would go back and try it again and see what you need to tweak. Okay. Next one, NR. And I want to find the length of NMP. So NR is given as 8, so let's label that 8. And let's see what arc we want to find the length of. So I'm going to label or highlight it in red, NMP. This is a major arc. So what's given right now is only 62. This is only M to Q. I need to find the rest of it. So in order to do that, we have some methods to work with, right? We have a diameter. Here. So I should be able to find this arc if part of the 180 is 162. So let's find all of these degrees here. Okay. Let's find 180 minus 162 gets us a total of 18 degrees. So each of these are 18 degrees because they are vertical angles. Okay. If we wanted to, we can label the other side as well as 162 since it's vertical angles with 162. Okay. Let's see the angle measure of the arc we want to find. So let's highlight that again. We have NMP. So we're going to add together 18 plus 162 plus 18 to get the total degree that we're going to use for our formula. Okay. So 162 plus 18 plus 18 gets us a total of 198 degrees. So we're going to use x as 198 degrees. Okay, this is 198 degrees. Right. So that's our x value. We have our r value. R is equal to 8 feet. So let's plug all that into the formula that we're using for arc length, and let's see what we get. So S equals, the arc length formula is x over 360 times 2 pi r. And I'm just substituting all of my variables with my values. Substituting x with 198 and r with 8. Alright. And you can use a calculator to help you simplify by multiplying all these numbers together. So I'm going to take 198 times 16 to get 3,168 over 360 pi. And I'm going to plug that into the calculator. And let's see our final answer here. We get 3168 divided by 360. And I'll take that number, 8.8, divided by, or times by pi. If you put that in the calculator correctly, you should get 27.65 feet. Last problem here. FG is 27. We want to find the length of FED, a major arc. So let's label FG as 27 first, so we can see FG is our radius. So we know radius equals 27 yards. Let's find the angle that we want to use for x. So FED is our arc that we're using right here. Okay. So we need to find this angle in order to use it as x. Alright, so let's go ahead and find that. We have 47, 80, and we also have a 90-degree angle here. And that leaves this big chunk here that's missing. But that can be found easily with 360 because an entire circle adds up to 360. So I'm going to take 90 plus 47 plus 80. I'm going to add all those together and then subtract it from 360. Okay. So I have 90 plus 47 plus 80 gets us 217 degrees. But I'm going to take that number and I'm going to subtract it from 360. So 360 minus 217 gets you 143 degrees. So I know now that this angle, the missing angle, is 143 degrees, which will be helpful when we want to find the angle we want to use. Okay, so let's take a look at that. Again, we're going to highlight FED, FED, It's this angle we want to find. So the degrees that we are using for FED are 90 and 143. So let's find the x value we're going to use. X is going to equal 90 plus 143. 90 plus 143 gets you 233 degrees. So the x value we will use in our formula is 233 degrees. So we have our radius, we have our x value for the degree, and let's plug it into the formula. So S equals x over 360 times 2 pi r. Plug in all our variables, we have r and x ready. 233 divided by 360 times 2 pi 27. And we're going to simplify it down. 233 times 54 over 360 and times pi. 233 times 54 gets you 1,252. So you should get 12,582 divided by 360 times pi. So I'll take all those numbers, multiply and divide to get S is approximately 109.80 yards.